Hello, everybody. I'm Dr. Suresh Azizi, and today I want to talk about international portfolio optimization. Imagine you want to invest in multiple countries. How do you choose what portion of your portfolio should be devoted to what country? That's the topic that today we want to investigate. Now, we wanted to do it quantitatively. Number one thing that we need is the raw data. So, how can we get the data for international stock markets? The website that provides data for international stock market is msci.com. And inside this, if you go to indexes, then you can get all the data that you need. So all we need to do is to go to this website, and then down here we can see that the data for different countries are provided, like for USA, China, and Pakistan, Sweden, Hong Kong, Philippines, Switzerland, Saudi Arabia, and much more. So now we are going to choose five countries, and we're going to try to optimize a portfolio consisting of these five countries. Now, so the countries that I would like to use here is Germany. So here you can search the country name and just hit the enter button. And here it gives you this. So I'm going to open up this, maybe in a new tab. And if you go down here, you can see that here we get MSCI Germany index, and then the first one is profile. Click on the second one, which is performance. And right here, you'll be given this. So the default is on 1 year, but also we can do 3 year, 5 year, 10 year. Let's do 3 years. So I'm going to just click on performance and then 10 year, sorry, 10 year. So, and after that, we can easily download this. So all I have to do is to just click on this and the data is downloaded. So if I want to write all the steps that I did, first I went to www.msci.com/indexes. And then on this website, I went to search the country and then click on performances, performance, click on 10 year, and then click on download data. So I'm going to do this for other countries as well to get my portfolio. So that was the first country. I got hold of that. The second country that I want to choose is, let's see, I can do this for Singapore. So Singapore, and right here, I'm going to open up a new tab, then go down, performance, 10 year, download data. After Singapore, I want to do Switzerland. Click here. And then performance, 10 year, download data. So I did Switzerland as well. Now, and sure that I did. Yes. Okay. After Switzerland, let's do Portugal. Portugal. Oh, come on. Okay. Open it up in a new tab. Performance, 10-year, download. And then the last one, I want to do Spain. So performance, 10-year, download. Now that I downloaded these countries, I'm going to just open them up. So starting from Germany, open it up. Here's the data. Now, if I take a look at this, I can see that this is monthly data. So it's like December 2015, then January 2016, and end of the month data for 10 years. So from December 2015 all the way to November 2025. So exactly 10 years of data. For Germany, I'm going to copy both dates and the data index and paste it here. So let me call this tab maybe calculation, and then this tab maybe explanation. So here I leave the first row blank and I'm going to paste it on second row like on a cell A2. Here, I just want to, so we are going to make many tables, and later on, I might forget that, oh, this was this, this was that. So here, I leave the first row for just the name of the table. So this table would be called maybe raw data. Okay, so I copied and paste Germany. Then what's next? So after Germany, let's go to next country that we have. I'm going to close maybe here. So, okay. The second country was Singapore. Let's go here. Open it up. Now I'm not going to copy the dates because it's going to be the same date. Open this up. Paste it here. After this, let me go to Switzerland, open it up, download data, copy the data for Switzerland, paste it here, and what else? I got Portugal, and here data for Portugal, and one last time, last country was Spain, so let's open up data for Spain. And here, data for Spain. Wonderful. And by the way, let me save my work maybe here. International portfolio, portfolio optimization. And let's save it here. Okay, so I wouldn't lose. So far, what did we do? And then maybe this date, okay, let me select everything here. And here, let's change that general to short dates. Good. Now, so far, I downloaded data for 5 different countries and I have them as values in my Excel sheet. Now, I want to invest in these countries. I have 120 rows of data and I want to invest in these countries in a way that my goal is to maximize return for different levels of risk. So the goal here is to make a portfolio and assign different weights to these different countries in a way that for each level of risk that I am willing to bear, I get the maximum amount of return. So that's the goal. If that's the goal, the very first thing that I have to do is to calculate individual growth rates for each country. So let me do this. Let me copy the first column, which is dates, then paste it here. I'm going to leave column G blank between these two tables because I don't want to mix them up. And then let me write the names here, Germany and oops. Since I'm really bad at spelling, I'm gonna be lazy here and then copy the names here. So copy and paste them. But so Germany, Switzerland, Portugal, and Spain. Spain. And so in this table, I want to calculate the return rate, yes, rate of return. So this table is called rate of return. Then I'm going to call this Germany underscore R and Singapore underscore R and Switzerland underscore R, Portugal underscore R, and Spain underscore R. Okay, now that you have all of these names, let me calculate the growth rates for each of these countries. How can we calculate the growth rate? The growth rate for any time series in mathematics is calculated. By the way, I don't need these data sets anymore, so I can just easily close them as I don't need them anymore. So, uh, to calculate, let me make this bigger. To calculate growth rates, in parentheses, rates of return. And in mathematics, in time series, in statistics, whenever you have a variable that it value changes from A1 to A2, the growth rate, if you want the percentage, growth rates as percentage, always calculated like this. So it's equals 100 times A2 minus A1. So how much it went up or how much it changed divided by initial value, A1. So this is the formula that I want to use. 100 times A2 minus A1 divided by A1. So if that's the formula, we'll go to the first column And here I can do this. I can say equals for 100 times, then B4 minus B3 divided by B3. And that gives me the percentage of change for Germany. And for other countries, I can just drag this to right, and then I can double click on this cursor points, bottom right, and it calculates it for everything. So far, I downloaded all the raw data from msci.com/indexes, and after that, I calculated the growth rates for each stock market index for 5 different countries. Now, uh, so the goal is portfolio maximization. The goal is optimization. The goal is to maximize return for different levels of risk. And by doing that, we can plot something that uh, we call it efficient frontier. So if I wanna do that, I have to first calculate the growth rate for each individual country and the risk for each country. So this table would be called. So first of all, let me copy all of these and then paste them here. And then I want to calculate, for example, monthly return, annual return, monthly variance, annual variance. Let me just write it. And one last thing, monthly standard deviation and annual standard deviation. So here I can call this table uh, AVG, averages, variances, and standard deviations. Okay, now I want to calculate these for these countries. Before doing so, let me name all these times, 5 time series that we have. What does that mean? Let me copy this Germany underscore IR and then select these time series, the growth for Germany. Now, right here, I can either paste this or just type Gemini underscore IR. And as soon as I hit enter, this time series is called now Gemini underscore IR. I can do the same thing for Singapore. So select the time series and then rather than J4, I want that to call that Singapore underscore R. And then Switzerland. Let's copy this and Switzerland and then Portugal. And then here, this one is called Spain. Okay, now I called all of these. Now, average return for Germany. For Germany, I can just say equals average. And then either I can just select these time series from here to end, or can I just say, for example, Germany underscore IR because I named that time series Gemini underscore R. Can we do that? Let's see. If I do this and if I hit enter, I'm going to get error division by zero. Because Excel doesn't know that when I say Gemini underscore R, I mean these time series. Somehow I want to let Excel know that, hey, I don't mean these letters, I mean the actual time series that this stands for. For that reason, I have to use a predefined function in Excel, which is indirect. I'm going to do this indirect function and then click here and close it and boom, Gemini underscore R. And now if I drag this to right, I can do this. If I didn't do this and if I wanted to calculate this, I could just do once for Germany, once for Singapore, once for Switzerland, once for Portugal, and once for Spain. However, what if I had rather than 5 countries, 50 countries or 100 countries? That would be really cumbersome. But in this way, it's super easy. After that is annual return. Annual return is just 12 times monthly return. Good. Monthly variance equals VAR. And as soon as you type VAR, you see two different functions, var.p and var.s. What do they mean? The first one is variance of population. The second one is variance of sample. Do we have population or sample? We definitely have sample. We have only 10 years of data. Even if we had all the years in the past, still we would use sample because we don't have future. Population means all the past years and all the future years, which essentially we don't have that. So I'm going to just double click on var.s or just one click and then use that indirect function. Then click on Germany and close the parentheses, drag it to right. Annual variance, just 12 times this guy. And monthly standard deviation. Monthly standard deviation is just SQRT, square root of annual variance. Here for annual STD, can I just say equals 12 times monthly STD? As a matter of fact, no, you cannot. So for this, I'm going to use SQRT, square root of annual variance. And you can see that 19 is not like 12 times 5. So as a matter of fact, it's square root of 12 times 5. But okay, we calculated all monthly and annual return variance and standard deviation. That's really good. Now, after that, what's next? Now I want to move from individual stocks to portfolio. So how do we calculate the portfolio return and risk? So portfolio return is essentially calculated like this. Let's say we have two different stocks. Then you can say W1 times R1, return of the first stock, plus W2 times return of the second stock. If you have five, you keep going. So portfolio return is very easy. However, there's a better way. We can use matrix multiplication. So that's M mults, and then you can just say like the return of these countries times weight matrix that we have. So as a matter of fact, we are going to be using this. How, in either cases, portfolio return is just easy. However, portfolio risk is a little bit different. Portfolio risk. Now, portfolio risk, what is risk? So, risk of one individual stock is usually defined by its standard deviation. However, a portfolio of stocks, its risk is not quite just W1 times standard deviation of first one, W plus W2 times standard deviation of the second one. It's a little bit different. Why is it different? Because not only it depends on the standard deviation or variances of these stocks, but also it depends on covariance or correlation, the relationship of these stocks with each other. Now, imagine we have, let's say, two countries or five countries, and these countries, let's say they all go up and down at the same time. In this case, diversification is not gonna help us reduce the risk that much because they go up and down at the same time. In that case, correlation coefficient between these countries is almost one. How about imagine if we had two countries that their stock markets would go opposite direction, or when one of them goes up, another one goes down. For any reason, I don't know, you can imagine two countries are in war with each other or something. Even when they're in war, it's not the way stock markets work. But however, just imagine we have two assets, two different countries, that when one of the returns goes up and it's positive, other one goes down. That that's a huge benefit, huge reduction in risk if we invest in both of them. Risk is essentially variation from expectation. From so, however, if one of them, when one of them goes up, another one goes down, and when one goes down, another goes up, they balance each other out. That brings the risk down for us. So, have you ever heard of this? Like, don't put all your eggs in one basket or diversify your portfolio. Why do we even have to diversify our portfolios? The reason is that correlation coefficient between these assets or between these stock markets is not one. So one time one of them is good, another time another one is good. So the risk of portfolio depends on not only the variance of each country's stock market, but also the covariance of these countries' stock market. So if I want to write it in mathematical form, it portfolio risk, which we show that maybe with RP, is usually defined as this: W prime times V times W. And what are these? W prime is transpose of matrix W. So matrix W is weights, like weight for these five different stocks that we have. And then V is something that we call variance covariance matrix. Essentially, it shows the relationship between return of different assets that we have here, that which right here is like these five different stock markets. So if we want to do that, if we want to calculate this portfolio risk, we must calculate variance covariance matrix. So variance covariance matrix, I'm going to do it right here. So the title here is variance covariance matrix. And then here, I'm going to copy these names. And then, so it's an n by n matrix. Right here, n by n means 5 by 5. So here, paste transpose. Transpose is horizontal, it makes it vertical. And now I want to see the covariances between these. So for that, I'm going to use covariance. Again, dot P or dot S. Which one should I use? You guessed it right. Again, dot S. So I'll do this and then array 1, array 2. Again, if I just click on W2 and then V3, and if I hit enter, I'll get error, division by 0. Why? Because I didn't use that indirect function. Here, Excel doesn't know that, I mean the time series that Gemini underscore R represents. In order to tell Excel that, hey, I don't mean the word Gemini underscore R, I mean the time series that Gemini underscore R represents. So I'm going to say indirect W2, and then here, indirect V3. If I hit enter, it calculates it for me. Perfect. Now, if I drag this to right or left, it's not going to be working. Why not? Because here, when I drag it to right, it drags this one to right, but also it drags here to right, which I don't want to happen. So I have to, for the blue one, I have to fix the row, and then for the red one, I have to fix the column. So let me go back here. I want to make the, here for the blue one, I want to make the row constant. How you can fix a row in Excel, just put a dollar sign before that. And here I want to fix the column, so I'm going to put a dollar sign before this. Good. Now if I do this, it's gonna work perfectly. Awesome. And I can double click on the cursor points, point at the bottom right. And as soon as I do that, it calculates everything for me. Did I do everything correctly? There's a test. The test goes like this. If I did everything correctly, then here the main diagonal 31, 26, 16, 29, 38 must be equal to these variances. But are they equal? 31, 26, 16, 29, 38. Yes, absolutely. So that means that I've done everything correctly. Now that I have variance covariance matrix, I can form my return and risk. Before doing that, I have to start from arbitrary weights. So I'm gonna use maybe I'm gonna make this table weights, and then copy the name of these countries. And right here, I just say point 0.2, point 0.2, point 0.2, point 0.2, point 0.2. And then here, I just call it total. And then total is SUM, sum. And then I open it up and add all of these. When I add all of these and I hit enter, it must be 1. So sometimes students say, oh, we know this is like 1, they add up to 1, they just type 1. That's a mistake. Do not do that. If you do that later on, you're going to regret it. You're going to face problems. Use this SUM and then have parentheses and open this W11 to W15. Oops. Okay. Now that I have that, I can create this matrix that I want. So the matrix that I want to make, Not matrix like the table, is called portfolio. And then here I have, let's say, return. And then here I have variance. And then here I have risk, which is essentially STD. So how do we calculate them? First of all, I want both monthly and then annual. Now, how do we do this? Monthly returns. So I have weight of each country and I have monthly return. So I could just say zero point 0.2 times this plus zero point 0.2 times this. However, much easier way is to just say equals, then m mults, that's matrix multiplication in Excel, and then this, comma, this. And that gives me the monthly return. So this means that if I had a portfolio of equally weighted countries, then and each of these countries had these returns, then the return of my portfolio would be this much per month. How much per year? 12 times that number. So this is going to be return of my portfolio. The variance is a little bit complicated. The variance formula is here, W times W prime times V times W. And this times is matrix multiplication. Yes. So I'm going to just write here that this, this is M mults, matrix multiplication is M mults. Now, so I'm going to use equals M mults. The first thing I had was W prime. So that's in Excel. We have this function transpose. And I can just select all of these. Transpose of that, that's exactly W prime. Good. So we did transpose of this, comma, array 2, that would be another M multi. The other M multi is this variance covariance matrix, comma, again this. Boom. And it gives me 21.24, which is the number, the monthly risk that we wanted. So great. Next, I have to calculate the annual variance, which is super easy, 12 times this guy. And then, so by the way, this is the formula one more time. Make sure you got it right. Risk is just, standard deviation is just square root of variance. And I can just drag this to right. Boom. I got the standard deviation of my portfolio. So I calculated the annual return for my portfolio, annual risk for my portfolio, and that's really good. And you can do this for any countries that you want. However, do not include the United States. The reason that we shouldn't be including in the United States is that United States dominates almost all other countries, maybe with one or two exception. I know Peru has higher rate of return than the US, and Japan has a lower return than the US. However, almost all other countries, this US stock market dominates them. What does that mean? It means US has a higher return and lower risk than almost all other countries. So if you do this, if you include the United States, then your portfolio would be mostly the United States. There's nothing wrong with that. However, it's not interesting. It's gonna be a portfolio of only United States. Okay, now from now on, we want to do this. We want to maximize return for different levels of risk. For that, we have to use something that's called solver. What does that mean? So if you go to right here, data, you can see that there's something called solver. However, it's a add-ins. What does that mean? It doesn't come with Excel. You have to add it in. How can we do that? On Mac, you can go to Analysis Tools and then click on Solver Add-in and then click on OK. And that would be added to your data tab. On PC, non-Mac computer is a little bit different. You're gonna go to Files and then Options and then Add-ins, add, and then from there, and now from Analysis Tools, you can just add in. At the end, so again, Files and Options and Mac doesn't have that, yes. It's a little bit different here, but on PC, go to File and then Options, Add-ins. From Add-ins, click on Analysis Tools and then click on Solver. And then click on Go. Do not click on OK. You must click on Go. And when you do that, you're going to have this Solver thing. Solver gives us the opportunity to do maximization, minimization problems. Great. How can we do this? How can we do maximization? So first of all, uh, let's get to know this. Here we have set objective. This is the thing that you want to maximize or minimize. Now, here I want to maximize the return. So for my set objective, I just click on annual return. Cell X20. Okay. Sometimes it does say calculation slash because I named this tab calculation slash X20, so it is 100% okay. By changing variable cells, what is the tool in your hands to when you want to optimize the portfolio, when you want to maximize the return for different levels of risks? What is the instruments that you have available? The instrument that we have available are these five uh, weights. Now, next one is subject to the constraint. So we have a bunch of constraint. Constraint number one is that these weights, we want them to be positive. We are excluding the notion of short selling, so we want them to be positive or zero. So that's one thing. Number two thing is that we want to add this condition that I want total to be exactly 1. So I change that to exactly equal to and then 1. So then I click on OK. The third thing I want to do is this. So I don't know what's the minimum risk that this portfolio will have. I don't know what's the maximum risk that it will have. However, the goal is this, to find the minimum and find the maximum and then find maybe 7, 8 points in between and then connect those points. And for each level of different like risk, I want to maximize the return. So I'm going to impose one more constraint. And here the constraint on annual risk. And I want this to be less than a ridiculously low number. I know that Excel cannot do this. However, when Excel cannot do this, Excel is not gonna is not going to stop trying. It's going to try, but it gives you the minimum amount of risk that your portfolio can have. And by risk, I mean annual standard deviation. So as soon as I click on OK here and I click on solve, so then one more time, keep solver solution, OK, it gives me this number 13.747, almost 13.75. What does that mean? It means that the very minimum risk that my portfolio can have is this 13.75. It is impossible to go below that. There is no way my portfolio can have a risk below this. By the way, this annual risk is less than all of these numbers. So it's less than all of these numbers, and that's a good thing. So when you combine the portfolio, it amount of risk goes down less than any single one of these countries. However, as you can see, Switzerland has the highest rate here. Essentially, this is telling you that if you want to achieve the minimum amount of risk, you're going to put $0. If you have $100, put zero on Germany, put zero on Spain, put $70.70 on Switzerland, $20.25 on Singapore, and $9.03 on Portugal. So 20%, 20 Singapore, 70.7% on Switzerland, and then 9% on Portugal. Now, every single time that we do this portfolio optimization, Excel does this. Excel uh, overwrites the numbers that we had in the past. I don't want to lose my numbers right here that they gave me the minimum risk. Since I don't want to lose, I would just copy them and then maybe I can paste them right here. How about if you just paste them like this? It's going to give you this hashtag value. You have to paste them as values. So I paste them as values. So I got my minimum risk. Now, what's the maximum risk? Let's find out. If I want to do maximum risk, I can easily go to solver and then change this from 0.0001 to like a number like ridiculously high, like 10,000. And then just click on OK. So I'm telling you, there is no way in hell that the risk of portfolio would be that much. Essentially, I'm making this condition right now ineffective. I'm telling Excel that, hey, I don't care about risk. Just maximize the return, no matter how much, no matter the risk. And I tell Solver to solve. Okay. The solver tells me that, hey, if you want the maximum return, just spend all of your money on Spain. And that gives you 21.489. As a matter of fact, if I take a look at this, when you put 100% of your money on Spain and zero on all other countries, the risk of portfolio is exactly risk of Spain, and amount of diversification is zero. We are putting all of our money on just one single country. So now let's go all the way to right. Maybe here BA, and then paste it right over there. Ah, what happened? One more time. Let me copy all of these. And then here, let's go to BA, paste. And whenever you paste, you have to paste them as values. Great. Now I can see that my maximum risk is 21.5, and then the minimum is 13.7. So let me see, 13.75. So risk is for this specific portfolio. You choose other countries, you might get different numbers. But for this one, 13.75 to 21.5. Yes. Risk is between 13.75 and then 21.5. So, and I want to do this maybe seven more times, eight more times. So if I go up one unit at a time, that should be good. So each time I'm going to say maybe 14 points. So the limit that I put for my risk is going to go up from 13 point this 747 to 14.75, 15, 16, 17, 18, 19, 20, and then the maximum. So when you want to do this solver these times, the good news is that you don't have to change that much of stuff. The only thing that you want to change is maybe here change this to uh so only thing I would change is this 14.75. And then click on OK, click on solve, OK, and boom. And while you're doing this, just make sure that each time you're paying attention that annual risk is 14.75, so everything is good. And interpretation means 11% Singapore, 64% Switzerland, and Spain 245. And we are not using Germany or Portugal. So here, I paste it right here as values. Go to solver, change this to 15.75. Click on OK, solve, OK, 15.75, 0 Germany and Portugal, and then this combination of these three countries. Nice. Then values. One more time. Change this. 16.75. Solve. Okay. Got all of these weights. Now we are down to only two countries, Switzerland, Spain. And I bet as we go ahead, weight of Spain gets bigger and bigger because at the end we have only Spain. So right now Spain was 53%. Let's change this to 17.75. And let's copy this, have this as values a few more times, change 18.75. Okay, copy this, paste values, change this 19.75. Paste it here. Values. So the maximum was 21. So I'm going to do 20.75 as well. Hmm. Okay. So one more time here. Change 20.75. Solve. Okay. And then paste. Paste values. Great. Now I calculated this many times and I have enough data and I am ready to make efficient frontier. However, before doing efficient frontier, I want to do one more thing. I want to maximize Sharpe ratio. What is Sharpe ratio? Sharpe ratio is defined as this. Sharpe ratio is defined as, so in the numerator, we have return of portfolio minus risk-free rates. And then in the denominator, we have uh, the risk of portfolio. The risk of portfolio is uh, just portfolio STD, annual STD, yes. But sometimes like we show that with Greek letter sigma, I'm gonna just write risk underscore P. So that's the Sharpe ratio. So Sharpe ratio, what is RF? RF is risk-free rate, essentially risk that Federal Reserve, like in the US, is like the risk that the rates that Federal Reserve provides to, uh, let's say, 1 year uh, to 1 month bill, treasury bills. So it's called risk-free because Federal Reserve never ever defaults on their promises. Now, financial promises. Uh, so right now it's around 4%. So let's assume that uh, level is 4%. So if we assume that risk-free rate is 4%, risk-free rate is 4%, then I can just make this Sharpe ratio is defined as, so, and then we can just do annual, yes, equals this guy minus 4% divided by risk of the portfolio. Now, one more thing so that we want to do is max. So we right now we just calculated the Sharpe ratio for this specific portfolio. Now I want to change these weights with the goal to maximize my Sharpe ratio. So I'm going to go here and then right there I can set objective, change the set objective to, it's going to be x23. So let me change that to x23. And so this is the thing I want to maximize. By changing variables, again, that's going to be the same thing, the weights. I have the first condition, second condition, but I don't have the third condition. What does it mean? It means that now I can relax this because the risk of the portfolio is already in the denominator. So I'm going to just delete this condition, and we're going to have only these two conditions that all the weights must add up to one and all the weights must be zero or positive. There's no short selling. And I just say solve. And we can see that the maximum the Sharpe ratio when is like 0.446. So I can write this, maybe somehow copy this, and then maybe write it here as values, uh, paste values, and then I would just write here max Sharpe ratio. So later on, I would remember this. This is a portfolio with maximum Sharpe ratio. If I wanted to put that in between of these, it would be 14.89. That's the risk. So it would be somewhere between these two. So somehow I can move these a little bit to right. If I just delete all of these and then paste them right here. And then somehow I'm gonna smuggle this portfolio because the point with max Sharpe ratio is also located on the efficient frontier that we are gonna graph that in a second. But here I pasted this here. Now, great. So far, I for different levels of risk, I maximized the return of my portfolio. Wonderful. Then we want to graph plots this plots efficient frontier. How can we plot this efficient frontier? Make a table, make a table with all risks and returns. So first risks and then returns. So I'm gonna make a table right here maybe. So yeah, then I would say risk. STD. So remember, we want to always minimize the risk. Yes, we want to limit the risk. We don't like STDs. And we want to maximize the return. Return is a good thing. Now I can just copy all of these different amounts that we have. So in on Mac, you can just select, click on one of them, and then hold the command button down, and then select all the rest. And then at the end, copy all of these numbers, copy, and then here, paste. Same thing for return, command. So click on the first one, then command, then click on the second one, third one, fourth, fifth, sixth, seventh, eighth, nine, and 10th. Boom. Return. Oh, why do I have one more return? Okay. I didn't copy this risk. So let me copy also this risk. Wonderful. So I got a table of risk and return for these 10 different portfolios. Yes, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now all I have to do is to just select all of these things. I'm going to select everything. Go to Insert, go to scatter plots, which is the second column, last row, and between all the scatters, I'm going to select this one. So that gives me the scatter plot of efficient frontier. Let me move this here and just I'm gonna make this bigger. Maybe call this efficient frontier. Frontier. And you can add chart elements, axis titles, primary, horizontal. I'm going to call this risk in parentheses STD of the portfolio. And click here, axis title, primary vertical. Let's call that return. So far, we made this efficient frontier. Now, what if I wanted to just have 1 point? Now we can add something to this table, something that's called capital allocation line. So first of all, which portfolio should I choose? Here, 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 all up. That's up to you. It depends on the level that you are willing to take risks. However, you should not, the points that you should not choose are points below this. Like let's say a point like Germany, or a point even like let's say Switzerland. Switzerland is return is 9.96, so almost 10, and then risk is 14.19. So Switzerland is 14.19, and then this is 10. So Switzerland would be right here. So Switzerland would be below efficient frontier. As a matter of fact, all of these single countries would be below efficient frontier. Only one country is exception here, Spain. Spain is located right here. But all other countries, they are located below efficient frontier. That's not, so we should not be just investing in those countries 100%. Like we shouldn't say, maybe, I think I said that sentence really incorrectly. We shouldn't spend 100% of our money in one single of these countries because it's below efficient frontier. It means that you can do better. For the same amount of risk, you're able to, with diversification, you're able to make a higher return. So it is possible to do that. And if it is possible to make a higher return, that's a good thing. Do that. So diversification, you can say either it increases the return for same amount of risk, or it decreases return for decreases risk for same amount of return. So if you are at a point like here, you can either go up and make higher return for same amount of risk, or you can go left and make less risk for same amount of return. We want to be on points above efficient frontier. So again, this is return. So everybody loves higher return. As a matter of fact, that's the definition of rationality. However, we cannot. It's impossible to be there. It's just a dream. Now, we can make something called capital allocation line. Capital allocation line also helps us really like a lot to uh, make a decision. For capital allocation line, we need again this risk and return. So this was efficient frontier, frontier, frontier. But let's move to one more thing that helps us making decisions how to invest. Next thing is capital allocation line. Capital allocation line. And again, we have these two things, risk and return. But we're going to have only 3 points for these. Point number one is going to be risk-free rates. So risk-free rates, risk is zero by definition for that, and we assume that return is 4%. Another point on this efficient frontier is the point with highest maximum, with highest Sharpe ratio, which was what point? This point. So this point, risk is this much, and then return is this much. Great. And then one more point on this capital allocation line that we can make is this point. So it's a line, yes. If you have two lines, two dots, 2 points on the line, you can get hold of any other points. So for that line, I want risk to be double than this risk of uh, max Sharpe ratio. So here I'm going to say 2 times this. And then this one I have to calculate. How can I calculate this risk? So essentially, this CAL line, capital allocation line, the y-intercept is this 4 that we have. So it's 4. And then the slope of this is max Sharpe ratio that we have. So slope of this line is max Sharpe ratio. We got it right here. And then so it's going to be this 4 plus max Sharpe ratio times this value of x that we calculated. Boom. So we got 3 points on these lines. All I have to do is to select these points and then make a graph. However, if I just do this, it's not going to overlay or superimpose. If I do this, and if I just do this, go to insert and make a graph, it's gonna make another graph. That's not what we want. We want to overlay this to this graph. In order to overlay two graphs on the top of each other, uh, one way that we can do is so we can uh, just here go to there are like different ways that we can do this. One of the ways that we can do, all I have to do after clicking on this chart is to go to chart design, and after chart design I can just uh, do select data. So chart design, select data, and then click on this plus sign, series 2, and then you can do this. First of all, name this series capital allocation line. On PC, it's a little bit different. I'm using Mac. However, the general thing is the same. You go to chart design, you go to select data, there is a plus sign, you click on that, you give a name, then you choose your X values. Select on this. X values are these 3 points. Then select Y values. Uh, boom. Oops. These are the Y values. And okay. I mean, uh, our capital allocation line is much bigger than the efficient frontier. The reason was that like the risk of these 5 different countries They were like very correlated. Therefore, the risk was just between them. The risk was not a huge range. It was between 13.75 on up to 20, I don't know, two something. But essentially here, this is capital allocation line. Capital allocation line, uh, if we could just see this, is tangent to efficient frontier. It's almost, yeah, we can see that. Its capital allocation line is tangent to efficient frontier. At what point? At maximum Sharpe ratio. So sometimes this maximum Sharpe ratio is called uh, the tangency portfolio, and many people choose this tangency portfolio. However, depends on your risk tolerance. You can choose to be at points, other points of the portfolio. It is possible to be at points to the left of this. So it doesn't make sense to be honest, at this point. You can, rather than being at this point, the point with 13.74 risk and return of 9.83. Rather than that, you can be on this point on capital allocation line, which gives us a little bit of higher return. How? For example, you invest 10% of your money maybe on risk-free rates and 90% on the tangency portfolio. If you are allowed to, if you can borrow money at risk-free rate, which is almost impossible. So the only person or institution that's able to borrow at risk-free rate is the Treasury itself. We cannot do that. But if we could do, then we could just be at points, we could use leverage and we could be at, like on this line, we could be at points like this. So if we could, for example, if you have $100 in your pocket and if you could just borrow $100 at risk-free rate, you could be at this point. So you could spend $200, you could invest $200 at tangency portfolio. Or if you have $100 and you could borrow only $50, you could be at this point. So you could spend that. This means you're spending $150 at tangency portfolio. Okay, with that being said, we are done. This is how we can use international markets and we can optimize a portfolio of international countries. It can be any different countries. However, if you choose a country like the United States, it's gonna overwhelm the whole portfolio. Like here, as you saw, like Germany was zero all the time for all of these 10 different points. Now, if you include United States, for the most part, all other countries would be zero. So, if you're doing a project, I recommend not including the United States of America in the portfolio because it dominates the whole portfolio. And then you can have a very beautiful, efficient frontier line, and then the CAN line and the tangency portfolio. Thank you very much, everybody, for listening. Have a wonderful time.